Yes, sir.
Good morning, everyone. It's my privilege to introduce Dr. Deepali Ora. Uh, Dr. Deepali working as professor and head of the Department of Information Technology in Vidyalankar Institute of Technology, Mumbai. Madam she has her PhD in Computer Science and Engineering from Amity University, Mumbai. And Dr. Deepali has more than 2 decades of experience in teaching, research, and industry. She published more than 50 research papers in reputed national and international conferences as well as journals. Dr. Deepali also co-authored 3 books as well as 2 book chapters. And Dr. Deepali delivered various technical talks in the domain of data science and machine learning. She also conducted several hands-on technical training programs in the domain of data science using Python to students and faculty across India. Dr. Deepali is a key syllabus revision committee member with Mumbai University, and she developed a lot of course content for BE in information technology. Dr. Deepali received several grants from AICTE, IST, and several national level statutory bodies. Dr. Deepali also rendered her services as reviewer in many international conferences which are organized under IEEE Access, IGI Global, and Journal of Big Data Analytics, and Journal of Intelligent Systems and Inter Sciences, etc. Dr. Deepali also organized several value-added courses for the benefit of students which are concerned to at Mumbai University. And Madam rendered her services to nearly 18 students, and 3 students are pursuing their PG under her guidance. And, Dr. Deepali developed a dedicated course content in the domain of deep learning, and which is at present available in the Unschool platform for all the digital learners. Madam, on behalf of Sri Vishnu Engineering College for Women and on behalf of Department of CSC and on behalf of the organizing committee of this international conference, we all welcome you for your keynote address on the theme of moving from machine learning to deep learning. We heartily welcome you, Madam.
Thank you, sir. I will share my presentation. I hope you are able to visualize my presentation.
Yes, madam. Yes. No.
Yes, madam, it is visible.
Yeah. So my topic for today is moving from machine learning to deep learning. Myself, Dr. Deepali Bora. Just 2 lines about my college. Vidyalankar Institute of Technology is situated in Mumbai, central Mumbai, and has 5 streams, mainly IT, computer, electronics, telecommunication, and biomedical. We have 3 PG courses in IT, computer, and electronics and telecommunication, as well as we have PhD courses in computers. It's been 20 years the Vidyalankar is there and providing services to the students. This is just the outline of my presentation, where I'll be talking about just about few slides of machine learning basics and what are the important tools in machine learning, because we talk a lot on theoretical basis, but we do not understand what are the major tools which are available, options which are available for the development. And it's very good to know these tools and try hand on this. Then we'll be moving slowly from machine learning to deep learning, understanding why it is important and how the transition has happened, and then few basic models in algorithm deep learning, and few applications. And with that, we will see what are the specialized tools which are available for the deep learning algorithms. So let us start with the introduction to machine learning. So all of you know what is machine learning, and it has been a buzzword in so many days, so many years we can say, and we all are talking about it. So these are few of the formal definitions of machine learning which are very popular and available. So I would like to highlight three terms in this particular slide. That is experience E, which is nothing but a data, and task T, which is nothing but what we want to do with that particular data. And whether we are going in the right direction or not, that will be measured by the performance measure P. So whether we talk about machine learning, whether we talk about deep learning, these three E, T, and P plays a vital role when we develop any algorithm, any application in the machine learning area or in the deep learning area. We must be very sure about what data we want to use. We must be very sure about what we want to learn, want to do with that particular data. And we should also find out the proper measure, the performance measure, to understand whether our machine is learning properly or not. So these three terms are a key to any machine learning model or the deep learning model. So if we see a very basic formation of machine learning, we can say we can represent any machine learning or the deep learning model as a simple equation as y is equal to f of x, where we can say y is our output variable, x is our input, that is nothing but our data, and f is a function which will transform this data so that we are able to generate the output y. So this is a very simple definition. Though it looks simple, it is not so easy to predict why. Identifying a proper function f which will transform our data to get y is very important. So let us see a few examples where machine learning is being used very nicely and have shown drastic improvements. The first classic example is the text classification. So I am in the office and there are many files which are coming in the office automatically. So I want to just classify that this particular file belongs to the account section, this particular file belongs to the, say, manufacturing department, and all that. So that can be easily done with the help of a machine learning model, where we can train the machine learning model based on the types of the file, and then it can predict once the new files comes that the file goes to which particular department. So text classification. Another classic example we can thought about machine learning is disease diagnostic. So nowadays even Google and all are working on disease diagnostic and healthcare analytics rigorously to identify the disease of any particular or diagnosis of any particular disease at an earlier stage. So we have a patient's data, and based on that particular patient's data, if a new patient comes and the data is fed, we are able to identify the presence or absence of any particular disease. Specifically, a lot of research has been going on onto the cancer related data, so that it is easy to identify the cancer at an early stage. On the same line, we have lot and lot applications of machine learning, right from recognizing facial patterns. Now also in pandemic, you can see that face mask detection and all those systems were widely used by many of the countries to identify or to warn the users that you have to use the face masks. Or even many solutions are provided using machine learning and deep learning to fight the COVID, regarding that the social distancing has been followed or not, to check that. So many examples are there. Then generating various images, patterns, motion sequences automatically is one of the major area of applications of machine learning. Then recognizing anomalies like credit card fraud detections and unusual patterns in sensor reading, so that we are aware that some natural calamity is happening or not, or even in a nuclear power plant. So there also the machine learning has shown its wide interest and wide application. Then future stock prices or currency exchange rates, so there also machine learning is playing a vital role. Web-based applications, and everywhere we can find out that the machine learning is playing a role in retail analytics, in spam filtering, in the recommendation system, and in information retrieval, finding the documents over the nets or images with the similar contents, what we talk about image mining and all. And even machine learning and deep learning are playing a vital role in visualization of the data. When we have large data available, so pinpointing which part of that data should be visualized and should be tackled, that is when best guided by the machine learning and deep learning models. So just have a look at what are the types of machine learning which has been categorized very broadly on supervised, unsupervised, and reinforcement learning. Everyone knows, I hope everyone knows about these categorizations. So when we talk about supervised learning, It is widely used when we have a data, we train our model on that particular data, and then we give a new data so that the prediction or the classification can be done based on that particular data. So regression, classification, and prediction are type of algorithms which we call or categorize as supervised data. Many famous regression techniques like linear and polynomial regression, logistic regression are famous in machine learning. As well as for classification, we can have logistic regression, decision trees, random forest, and ADA boost algorithms and all, which are very famous for the classification under the supervised domain. Then we have new category as unsupervised learning, where we have only the data and we want some results, some categorization of that particular data. So typically the task like clustering and all is comes under unsupervised. So we want to group the documents, we want to group the items, we want to group the users. So those kind of tasks can be done with the help of unsupervised machine learning models. So clustering, association analysis, and those hidden marker models are playing a vital role in unsupervised machine learning. And then comes the last part of machine learning models, that is reinforcement learning, where we are only targeted to have the last result. Like we are playing in a chase and I want to know whether I am going to win or not. So intermediate steps are important to reach the goal, either win or loss. So that is nothing but reinforcement learnings. And nowadays, a lot of research has been going on in reinforcement learning in identifying the goals and all those kind of things. So these are the tasks which are there in machine learning, and subsequently these are the tasks in deep learning also. Deep learning being a part of machine learning, everything right now I'm talking about is very well applied on the deep learning also. So we have a regression task where we can predict say daily customer analysis or daily what you can say stock analysis I can do with the help of regression kind of thing. Then classification is nothing but categorization of the data into the known classes. So I can have say multiple number of classes and I want to categorize the items, the users. So that can be done with the help of classification. The prediction based on that can be done with the help of classification. Clustering is nothing but grouping of the data. So I have customers, so I want to group the customer based on their liking, based on their say post on the Facebook, based on what kind of advertisements they say, based on their buying habits. So all that can be done as a clustering. Then we can have association, which is nothing but market basket analysis. So based on one kind of association, I want to find out. I want to find out the relationship among the items, or I want to find out the relationship among the web pages, so that I can very well associate or create a structure of my website. So machine learning can help you out in doing this. And the last and the least is nothing but outlier analysis. So a lot of data is there, regular data, but there are some outliers. And all the time, in some of the cases, these outliers are very important. Like when I am doing the network analysis, when we want to find out the credit card fraudulent transactions. So in that case, or penetration, when I want to find out who is penetrating my network, in that case, the regular cases do not help, but these unusual cases or outliers help us out, find out the pattern or identify the threats or attacks to our system. So these are the few popular tasks in machine learning. So why everybody is talking about machine learning and all nowadays? That is because of only two things. Number one, we have a mass storage available cheaply right now. I have come from an era when there was I used to use 1 GB of hard disk, and I used to wonder, Arey baap re, I have that 1 GB of hard disk, and now we are talking about 32 GB of memory for a laptop, and we find it, Arey, that is also very less. So see the how we have large amount of storage which is available right now for processing, as well as we have a very good performance computers available at machines available at our end, high end machines available for analyze this data. That's why machine learning, though it has started its way back in 19th century, is being popular in 21st century because of evolution of data storage techniques and the availability of CPU and GPU at a very well rate. So this is just a spectrum. This I have taken this image from the internet, I like this image very much because it gives me a overall plethora of algorithms which are available in machine learning domain. So this is a 2 years back model. So now lot many more algorithms are added in this particular spectrum. But for any particular beginner or the person who is into machine learning and deep learning can understand what are the variety of algorithms which are available, and based on the task, based on what is the output expected, what I am saying, we can have we have a plethora of choice of algorithms to use. Nowadays more and more research work is going on into hybrid models. So though we have a state of the art models, so researchers are trying with the hybrid model so that they can get best of both the models and can come up with a common solution for their applications. So this is just a typical machine learning application pipeline, we can say. So we have a raw data, we have to clean that data, we have to make that data, we have to identify what data is applicable for our application, gives me a value, provides a value for my business. So clean that data, explore that data, understand its basic statistics, plots, trends, and patterns, so that I can very well understand my data, and based on that I can identify for which this particular data what kind of design or model is best suited. And then I can design or decide on that particular model. I can make my model learn from the data, and then I can put it for the experimentation in a real time scenario. And at the time of real time scenario, my performance measure P will play a vital role. And from there I can understand whether I am achieving my performance or not, whether I am moving in the right direction or not. If I'm not moving in my right direction, then there are two ways available. Either I can update and improve on my model, or I can relook at my data and find out if there is something more interesting in my data which can help me out in getting the output expected. And in all these process, the two persons I can say are playing a vital role. Number one, in whichever domain I want to apply my machine learning, so a domain knowledge expert is very well important. Like if I'm applying my machine learning for the extradition of crude oil, so when I am extracting my crude oil, I have to input some chemicals into that particular oil well. So in what percentage I should input those chemicals in the well, and in what way they should follow one after the another. If I am able to optimize that, then the crude oil production will improve drastically. So for that, for understanding that, I will require a domain expert who can identify what are the chemicals, what are the properties of the chemicals which should be analyzed, so that I can identify what chemicals and in what pipeline they should move into my pipe so that the oil extraction is maximum. As well as I will require a machine learning expert who knows with this kind of data what kind of model is best suited and how it has to be applied so that my oil production is maximum. So though domain expert is required, but we require expert, no, machine learning or deep learning expert who can suggest the model based on the data which is been identified by the domain experts. So these two, so our researchers are playing a role in domain expertise, as well as our researchers are playing role in gaining expert knowledge about the machine learning. And so the machine learning can be applied in a variety of domains in a very interesting way. Now let us have a look at what are the basic tools which are available for the machine learning implementation. There are plethora of tools available. I am just highlighting which are the tools which are most popular, easy to use. So three tools I'll be talking about are Python, R, and Java or Scala. So Python is very well and quite famous for the machine learning and deep learning algorithm. Researchers also love it because of wide availability of libraries, like scikit-learn library is very useful, and basic machine learning models are implemented, optimized, and easy to use in any of the environment. As well as these are all lightweight libraries, can be used experience with the embedded system or IoT based applications. So that is also has added a flavor onto Python, very flexible, less code is required to be written. And these are the few features of Python which makes it very well optimized for the machine learning applications. So Python TensorFlow is also one of the very famous library like scikit-learn. The TensorFlow has come up specifically for the deep learning models. So TensorFlow has come up with its own flavor with the tensors, that is nothing but n-dimensional matrices, which are very well used or are required in deep learning. So TensorFlow has been developed by Google and is very best suited for deep learning applications. For a traditional applications, we can very well go with the scikit-learn, but for a deep learning application, the TensorFlow is providing us a very good support. As well as we have Theano and Cafe, which are also based on Python and those kind of languages, and can provide a very good what you can say framework for machine learning in vision applications and image processing and video analytics applications. So these two are also very good framework for use with the machine learning. And then R is a statistical language, and it has been introduced for analytics purpose. So whichever are the analytics models we want to develop, or machine learning models for various kind of analytics we are expecting, R is the better choice for that. And it is also lightweight, gives a better performance when the statistical related models are to be applied. Then for those machines, like when in the era of with the deep learning, we are now talking about big data analytics and all. So when I want to go with the data engineering and all, and I want to go with the Hadoop like of systems, distributed system when I am talking about, and those systems are more or less based on the Java language, and those who are very well conversant with the Java language, they can always work with the Scala and Java libraries which are available for data engineering, for the big data applications, as well as for the machine learning applications. So Java machine learning libraries are available, and Scala is very useful when the data is lab, when we are talking about big data applications. And we can use Spark and Scala and Java for writing good machine learning algorithms. Now let us move on from this machine learning to deep learning. So everyone knows what is the deep learning. When we typically, the deep learning is a word which has been formulated with the neural network. So whenever, most of the time we are talking about deep learning, we are talking about deep neural networks, increasing the number of layers so that we can understand the data in a better way. So these layers are doing feature identification and processing in series of stages, and as our brains are working, and gives us the output. So that is all about deep learning. So let us understand a little bit of history of deep learning. Is it like that the deep learning has come right now? Now, if you look at the history, you can see that the history of deep learning can start from right from 1943, when Walter Pitts and Macula has developed the what you can say first, you can say the model based on the neural networks of the human brain. The earlier efforts in developing deep learning algorithms came from the Alexey and Valentine in 1965 also, when they used the models for polynomial activation functions that were analyzed statistically. From each layer, the best statistically chosen features were then forwarded onto the next layer. Then the next things came in 1979 with the evolution of first convolution neural networks, and the artificial neural networks were developed, which are called as neocognition, and which use hierarchical and multi-layer design. Then fortunately, the work further extended with the development of support vector machines in 1995, and the advances in AI and deep learning started gaining popularity from there. Then came your long short-term memory, which is a very popular deep learning model, and the recurrent neural network has been talked by our other guest speaker also. And then the next step, the major development started in 1999 with the development of GPU. So as the hardware has become cheap and the various resources were available, GPU computing hardware was available for computing the deep learning gained popularity. Then again in 2006, we can say the deep learning started gaining its popularity when he introduced the idea of unsupervised pre-training and deep belief network in 2006. So 2006 to 2009 can be called as a golden era for the deep learning, because how to train the deep networks, that research has happened in this era. And from there, the actual journey of deep learning algorithms has started. So in 2009, the AI professor at Stanford launched that ImageNet, which is nothing but he assembled a free database of more than 14 million labeled images. And that was used, these labeled images were needed to train the neural network, and the experimentation with the deep learning started. By 2011, the speed of GPUs had increased significantly, making it possible to train the convolution neural networks without the layer by layer pre-training. So with the increased computing speed, it became obvious that deep learning had significant advantages in terms of efficiency and speed. One example is AlexaNet, a convolution neural network whose architecture won several international competitions during 2011 and 12. And rectified linear units were used to enhance the speed, and dropout was also used. Also in 2012, Google Brain released the results of unusual project known as the CAT experiment. The free-spirited project explored the difficulties of unsupervised learning. The deep learning uses supervised learning, meaning the convolution neural network is trained using label data. And using supervised learning, a convolution neural network is given unlabeled data and is then asked to seek out recurring patterns. The CAT experiment used a neural net spread over 1,000 computers. 10 million unlabeled images were taken randomly from YouTube, shown to the system, and the training software was allowed to run. Currently, the processing of big data and the evolution of artificial intelligence are both dependent on deep learning. And deep learning is still evolving and is in need of creative ideas. So that is the theme of this particular conference, that we all come up as a research fraternity with the creative ideas, which in the development of deep learning applications which can be applied in a generalized domain. So why we all are talking about from machine learning to the deep learning is nothing but increase in volume of data. So with the traditional machine learning algorithms, when the size of data increases, the machine learning algorithms do not learn from that data. But if we, so then what is the need of this data? Or when we have that much of amount of data, and if my algorithms are not running, that means they are not suitable. So from here started the deep learning algorithms, and they gain the popularity because deep learning algorithms, as much data you provide to them, were started learning from them. This is another slide which will show you why we are talking about deep neural networks and deep learnings more often. So even medium neural network or shallow neural networks also do not give a good performance as and when the size of the data increases. But deep neural networks gives us a very good results. That's why we are talking about deep learning nowadays. So there is always a what you can say an fight whether we should go about a fat and a short network, or whether we should go for a thin and a tall network. So if we compare both of them, the number of parameters are same in a fat or a short network and in a thin and a tall. But right now it has been proved by researchers that the deep networks are providing a good performance and good results over a fat and a short networks. So this is one of the paper where the research was presented onto the finding a error rate on prediction of some word. So you can see that here, if I am using a fat and a short network with same number of one layer with more number of neurons, the word error rate is not drastically decreasing. But on the same line, if you go on increasing the number of layers with the lesser number of parameters, the error rate is drastically decreasing. So we can see that with the 7 layers and only the 2k number of parameters, we have achieved a remarkably good error rate as compared to one layer with 16,000 number of parameters. The improvement in word error rate is not there. So this experimentation has proved that thin and tall architectures, that means the deep architectures, are playing a very well good role in performance improvement, which is a goal of any deep learning algorithm. Why we are also thinking about why we are going in deep? So you can see, look at this particular example. Say I have an image and I want to classify this image as whether it is a boy or girl, or whether it is a long with a long or short hair. So inherently, my output is girls with a long hair or boys with a long hair and all that. And we can have a classifier where the first classifier will tell whether it is a boy and girl, and the second classifier can tell us whether the person has a long or a short hair. So we can see that here we are using a layer wise approach, and same is the concept of deep learning. So we go for a layer wise approach, the performance is improved, and we can train our model with little data, but we can gain a good performance. So these layer wise modules will always provide us a good modularization of the application or the problem at hand, and we can use less training data in every layer, and still we can get a good performance at the end and good output at the end. That inherently says that why deep learning is preferred nowadays over the simple machine learning, or why the thin and tall architectures are preferred over the short and small architecture. This is another example, like I want to analyze image, so I can go layer by layer, where in the image first I will go identify the pixels, then I will identify the edges, the texture, the motif, the part, and finally I can go with the image or the object identification. On the same lay, suppose I want to create a story, so I can start with the character will give rise to the words, then I can form the group of words, and then I can have a clause, then I can construct the sentence, and finally I can construct a good story with the help of various levels. So these are few of the deep learning applications, and intuitively they say that the layering approach is best suited when I want to achieve the output. So what are the very famous algorithms in deep learning? So deep learning, as the term indicates, any machine learning model which has more, or any algorithms which has number of layers can be called as a deep learning. But still deep learning has its own analogy of the model. So we can generalize it as a discriminative model, or we can say generative model and the hybrid model. So when we are talking about discriminative models, they are used for modeling dependency of unobserved target variable y on observed variable x. Whereas when we are talking about generative models, we are using it for the joint probability distribution. So under that, we can have various models, like discriminative models are CNN, deep neural networks, and recurrent neural networks. Whereas generative model, we can talk about deep belief networks, restricted Boltzmann machines, and regularized autoencoders. And there are few hybrid models which use based of both discriminative and generative, and can be used. So these are few of the traditional deep learning algorithms, and there are many hybrid combinations are present and can be used. So we have a stack autoencoder, where autoencoder is an artificial three or more layer neural network. So when I stack these autoencoders, I create a stack autoencoders, or stack denoising autoencoders. Those are the very popular algorithms layers. So we have an encoder, we have a coder and decoder to construct the input, and based on that generate whatever we wish to generate. On the same line, we have a deep Boltzmann machine. So deep Boltzmann machines are used for basically the classification, where the main unit is a Boltzmann machine, and then we stack the Boltzmann machine in a particular way, which is called as a restricted Boltzmann machine, and layers of restricted Boltzmann machine in a visual and the hidden layer forms the deep Boltzmann machines. And we can use deep Boltzmann machine effectively for the classification of the algorithms. They are very good at analyzing and learning difficult and abstract internal representations of the input. They are effectively used in tasks such as object identification, speech recognition, and what you can say, language processing. Then we have a deep belief network, which is a slight variation of deep Boltzmann machine. The unit is same restricted Boltzmann machine, but constructed in a very different way. So deep belief network is a probabilistic and generative model. They are made up of multiple layers of latent units, and they are interconnected in such a way that unit in one layer are connected with the units in a neighbor layer, and so on. So they are useful when limited training data is available, and they give a very good performance with the limited training data. Then we have a deep convolution neural networks, which are the where the basic unit is your convolution neural network, but with the convolution neural networks, more layers are organized, and we are constructing the deep convolution neural network. Then we have a recurrent neural network, which the ma'am has already talked about, where it is used for the sequential information, and a variation of that can be treated as a long short-term memory or a LSTM, where you have a cell and you have a memory cell which captures the data and will help you in the entire sequence what kind of data to be stored and what kind of data to be passed out. So you have various gates in long short-term memory which help you control the things. Fine. In this entire deep learning journey, these activation functions play a vital role. And these are the three very popular, what you can say, activation functions which are used in deep learning. That is the sigmoid, tanh, and ReLU. Particularly if we are talking about the deep learning, then activation functions like ReLU is most important in case of deep learning. I have one of my research paper available with this activation functions and why we should go with the ReLU and all. Your different challenges in deep learning like gradient descent and all those kind of what you can say problems can be handled effectively with the help of these activation functions. Activation functions adds a non-linearity into your network and very well are required to control the network, the parameters and the output. Much of your output depends on the proper use of activation functions. Giving a thought on activation functions when for any particular application is very, very important. Then what are the various applications? So these are few of the very famous applications of the deep learning. There are many, many, many applications. So like colorization of the images in videos. So previous many images are available. So we can use deep learning algorithms to color them, those black and white pictures. Then we can have a neural talk, a particular what you can say deep learning algorithm which is used for describing the photos. So if you give a photo, it will generate a caption and it will identify what this photo is all about, what this photo is talking all about. So this is a very famous what you can say application of the deep learning. Then self-driving cars nowadays, so much of research is going on self-driving cars. So deep learning is playing a vital role in this self-driving cars. And then voice generation. So Google has come up with a wavenet, and Baidu has released this deep speech. So you must be asking, see, what is the big deal? Like Siri and Alexa also can talk, but there is a vast difference between this and your Siri and Alexa. Today, these text-to-voice systems were not completely autonomous in the way they created new voices. They were trained manually. But the systems that are created today learn to mimic human voices by themselves and improve with time. So when letting an audience try to differentiate them from a real human speaking, it is much harder to do so. So that is deep learning, which is playing a role in your voice generation. Then we have a visual question answering system, which is also very much popular, where appropriate answers are provided to the questions asked. Like this, there are many, many and more applications of the deep learning. The large data is available and has made the deep learning research possible in various areas, like from natural language processing till video analytics. But to facilitate that, these deep learning tools are very, very important. So the majorly the most popular tool is the TensorFlow, as well as with that the PyTorch and Cafe2 are frameworks which are available for deep learning experimentation. And those who are very much familiar with the Unix like platform and all, for them PyTorch and Cafe2 are providing easy to use frameworks and can be used with the mobile devices effectively. Then Keras is a library, Python library, which has come up with many deep learning, what you can say, algorithms which are hard coded, and those can be run on CPU and GPU and can be used in any kind of applications. Then those who are very much in love with the Java, for them also deep learning 4J is a kind of library It is a commercial grade library, but open source distributed deep learning library, which can be used with your Apache Spark, Hadoop, and for the big data analytics and Scala platforms, as we had talked about. There are many challenges for deep learning, like they are very susceptible to the overfitting because large data is available, as well as these mathematical models are problematic for the numerical stability, mainly from the vanishing and exploding gradients. And many a times the model has sharp minima while converging, thus leading to overfitting. So many models are not robust also, thus may not sustain or produce the same results in the environment. With these many challenges which are available in deep learning models, still deep learning models are doing a great job in many fields. So it is today's requirement to start researching in this domain and find answers to some of these challenges and come up with a good deep learning applications. So these are the few of the research areas which I have listed, which will be useful. All of many of you must have been working already in these particular areas. So meta learning, even transfer learning nowadays with the GANs and evolution of GANs, adversarial networks and all. This transfer learning is also been a good research area, as well as your natural language processing with the help of these BERT and transformers, evolution of BERT and transformers. The natural language processing has evolved as one of the good research area. Then metadata learning or meta learning is one of the area, because a lot of data is getting generated. So analyzing metadata and generating applications which will work on this metadata. So that is also one of the very good research area in the deep learning. So with this, I'll just end my presentation. If you have any questions, you can ask. And I have my email ID written over here. So if you want to communicate me over the mail, so any one of you can communicate with me over my particular mail. Thank you. Thanks a lot.
Thank you very much, madam. It was really an insightful and wonderful presentation, which was in line with the theme of the conference, madam. And this
Thank you.
particular
Thanks a lot.
presentation has answered many of the basic queries, like when can we go for machine learning, when can we go for deep learning. And you have covered major mechanisms in deep learning, whether it is CNN or RNN, LSTM, and so on and so forth, madam. And it was our privilege to be associated with you like this, and hope this will continue in future also, madam. Thank you very much.
Yes, sir, definitely, sir. And thanks a lot for providing me the opportunity to be a guest of honor and a keynote speaker. Thanks a lot. And we'll be keeping in touch. Thank you, sir.
Thank you very much, madam. I think most probably I will call you after this one. Thank you.
Yes, sir. Thanks a lot.
Thank you, ma'am. I'm sure all the participants will have fruitful and rewarding exchanges in these 3 days. I wish all the participants every success with this important conference. And now I request all the participants to join in their respective tracks to start the conference. Please join in your respective tracks to start the conference.
Okay, thank you.